In this video, we're going to look at the fundamental theorem of calculus. Let's start with an example. We're asked to take the derivative with respect to x of the integral from 1 to x of e to the minus t squared dt. Let's recall the fundamental theorem of calculus. So for the fundamental theorem of calculus, we're taking the derivative with respect to x of an integral from a constant a to a variable x of a function f of t dt. Now this whole integral is actually a function big F of x, because when I evaluate this integral, the upper bound causes a variable to remain when I evaluate. So this whole integral is a function big F of x. So taking the derivative with respect to x of big F of x, using the fundamental theorem, it says we can just take our little f and evaluate it at x. So let's apply this to our example. In our example, our little f of t is equivalent to the e to the minus t squared. So using the fundamental theorem of calculus, my final answer is e to the minus x squared. Let's look at a slightly more complicated example. In this example, we want to take the derivative with respect to x of 1 to x cubed of e to the minus t squared dt. This case is a little more complicated because the integral is no longer a function big F of x, it's a function big F of x cubed. So we're actually going to do a u substitution to simplify this problem. So we're going to make u equal to x cubed. So my function big F of u is equal to the integral from 1 to u of e to the minus t squared dt. We can take the derivative of this using the fundamental theorem of calculus. So f prime at u is e to the minus u squared. To solve this problem further, we need to use the chain rule, because we're taking the derivative with respect to x of a function of x cubed. We need to take the derivative of the function, evaluate it at x cubed, and multiply it by the derivative of x cubed, which is 3x squared. So our final answer is e to the minus x cubed squared, plugging our x cubed back in for u, times the derivative of x cubed, which is 3x squared. So our final answer is e to the minus x cubed squared times 3x squared. Let's look at one more example. In this case, we're asked to take the derivative with respect to x of the integral from x to x to the fourth of e to the minus t squared dt. This example looks a little different than the other two because instead of a constant as the lower bound, we have another variable. So we're going to use some integration rules to split this integral into two separate integrals. So we can rewrite this as the derivative with respect to x of the integral from x to 1 of e to the minus t squared dt plus the integral from 1 to x to the fourth of e to the minus t squared dt. So we split the original integral into two separate integrals. The first part of this sum looks very similar to our first example. And if we switch the bounds, we can again use a rule for integration, which says that if you switch the bounds, you get the negative of the integral. So we're going to write this as the derivative with respect to x of minus the integral from 1 to x of e to the minus t squared dt plus the integral from 1 to x to the fourth of e to the minus t squared dt. This second integral we're going to solve similar to our second example, because this is really a function big F of x to the fourth. So we're going to find f prime at x to the fourth, and then multiply it by 4x cubed, which is the derivative of x to the fourth. So our final answer, from the first integral, we get minus e to the minus x squared, and then from the second integral, we get plus e to the minus x to the eighth times 4x cubed.